Okay, welcome to part 3, section 2 of our lecture video series from Wednesday, April 19th. We are talking about how to calculate pressure volume work, and I've given us a little example here. So let's talk about what goes on in your car's engine. So really simplified system here in this example, but in general, the whole operation of your combustion engine is the compression and expansion of various gases, specifically things like octane. So let's suppose that we've got gaseous octane in the cylinder of an engine, and it is compressed from 400 milliliters to 50 milliliters via a piston that exerts a constant pressure of 8 atmospheres. Okay, that is a lot of information. So what I'm going to do is I am going to first identify kind of my initial conditions of my system. So first of all, my system itself is the octane gas, because we are chemists. So when we define our system, we're always looking at whatever kind of like molecules, particles, reaction that's going on. Everything else, the container, yada yada, we don't care about. So I have initially octane in a cylinder of an engine compressed from 400 milliliters. So from 400 milliliters, this means this is my initial volume. So let's kind of maybe sketch out what's going on here. So my system's initial conditions. So I've got a cylinder whose total volume is 400 milliliters. And I know that I have my octane particles occupying all of this volume. All right, so that's what's going on initially. So gaseous octane in the cylinder of an engine is compressed. Okay, so I know that my volume is going to decrease from its initial volume of 400 mils to its final volume of 50 mils. Okay, so we've got our final system. So we've still got kind of our original 400 milliliter cylinder. Like this is still the total volume of the cylinder. However, the volume of that cylinder that my octane now occupies is limited. I'm down now to just 50 milliliters. So about 1/8 of the space. And how is it that we were able to be compressed? So how is it that now the new volume of my system is 50.0 milliliters? So I was told that this compression was able to happen because a piston, which is literally what you see like when you have a syringe that you're trying to depress. So a piston has been utilized to compress our gas. And we know that that piston is exerting a pressure of 8 atmospheres, right? That's what we were told about our piston. Piston exerts constant pressure of 8 atmospheres, where the atmosphere unit is a pressure unit. So I could say that the pressure of my piston is 8 atmospheres. Okay. What am I trying to do? Calculate the work that's involved in this system in joules. Now notice I have been vague. Calculate the work involved, because I am trying to get us to understand whether a system is being done by the system on the surroundings or being done by the surroundings on the system, and what sign should be. So we can go back and check what we know about compression, right? We looked at compression earlier in our notes. Let's save that as a way to check our sanity later. So let's start by writing out our equation for pressure volume work. So work is equal to the negative of external pressure that our system is fighting against times the change in volume of our system. So let's see if we can't identify what the external pressure that our system is fighting against is. So we had our octane molecules that were in this 400 milliliter space, and then pushing down on them was this outside force, which was our piston. So the thing that is external to our system, that is applying a force that we are fighting against inside our system itself, is the piston. And that's our 8 atmospheres of pressure that is being applied. So the external pressure is going to be our 8 atmospheres. And I've made that negative because of my actual definition of pressure volume work. Okay, now let's look at our change in volumes. That's going to be final volume minus initial volume. And let's be a little bit careful here. I gave us information that told us how to get our work in joules, because remember, anytime we're talking about heat, work, energy, we're always going to use the standard unit of joules. And I've given us a way to convert to joules based on the liter times atmosphere unit. So I've definitely got the atmosphere unit, because that was the pressure in that my piston supplied, right? This was the pressure given by my piston. However, that means that my volume needs to be in liters. So let's figure out our change in volume in liters. So I'm going to actually do my initial volume here, convert milliliters to liters. I'm going to move my decimal to the left 3 places, or I'm going to divide by 1,000. So this becomes 0.400 liters. And then if I'm going to look at my final conditions, VF, moving my decimal over again 3 places to the left, or dividing by 1,000, becomes 0.0500 liters. And so if I'm going to calculate my change in volume, delta V, that's going to be my final 0.0500 liters minus my initial of 0.400 liters. So that's going to be my negative 8.00 atmospheres times, let's see here, when I do that difference, what do we get? So 0.05 minus 0.4 gives us negative 0.35, keeping my decimals is my least precise number for sig figs, so it's 350, and that is liters. So I've got a negative times a negative, which will give us a positive. So this will be 0.35 times 8. So I get 2.80 liter atmospheres, atmospheres times liters. So my work is 2.80 liter atmospheres. And now let's convert that into joules. So I was told that 1 liter atmosphere is equal to 101.325 joules. So should be a little over 280. Yep, I get, let's see here, negative 283 points, and then let's see here, 71. So I need 3 sig figs, but I am gonna wait to round. Excuse me, it's not negative, it's positive. So then with significant figures, work is positive 284 joules. Okay, I know both the value or magnitude of the work that's happening here during this compression. And now what I really want to do is I want to focus on this sign. So since work is positive, is the system doing work on the surroundings, or is the surroundings doing work on the system? So again, anytime we see a negative, that means that we are going from system outward. So anytime we've got system to surroundings, the sign is always going to be negative. So this is away from or done by the system. Anytime it's the opposite, however, so the surroundings is doing something to our system, the system is taking it in, right? Positive. So this is into or done on system. So based on just the sign of our work alone, we would predict that work is done on the system by the surroundings. Okay, let's go back up now and check our sanity and see if that is what we saw with compression, right? Because that's what's going on here. We're being compressed. Aha, compression. The work is done on the system by the surroundings. So we should have work done on the system by surroundings, positive sign. So if I wanted to be a little bit more, I don't know, clear, fancy, explicit here, I could say that 284 joules of work is done on the octane by the piston in the engine cylinder during this process. Where the piston, the cylinder, and the engine that contains it, those are all the surroundings, and the octane itself is the system. So work is done on the octane, the system, by the surroundings. Okay, that is how we calculate pressure volume work. Up next, let's at least get started in our conversation about how to quantify heat, Q. So we've done pressure volume work W. But now let's look at heat. So we'll at least begin this conversation coming up in our next video.